Welcome to Stellar Equation, where science meets wonder and the unseen universe comes to light. Let's begin.
Imagine standing outside on a quiet night, looking up at the sky. Every star you see, every galaxy shimmering in the darkness, is held together by one invisible force. Gravity. We feel it every day. Air feet pressed against the earth. Objects falling when we let go. But what if I told you that this familiar force is also the architect of the cosmos? Gravity is not just a force pulling apples from trees. It is the shaper of galaxies, the designer of stars, and the weaver of spacetime itself. In this journey, we will explore how gravity sculpts the universe, bends the very fabric of reality, and continues to baffle even the greatest minds in physics. Let's begin with what we know. On Earth, gravity seems simple. It keeps us grounded, makes rivers flow downhill, and gives weight to everything around us. But for centuries, the true nature of gravity was a mystery. Ancient civilizations noticed that objects fall, but they could not explain why. It wasn't until the 17th century that Isaac Newton revolutionized our understanding. He proposed that every mass attracts every other mass, with a force proportional to their size and inversely proportional to the square of their distance. In Newton's universe, the same force that makes an apple fall also keeps the moon in orbit around Earth and planets circling the sun. It was an idea so simple, yet so powerful, that it became the foundation of classical physics. Newton's laws worked beautifully for centuries. But in the 20th century, Albert Einstein shattered that picture with something far more profound. In 1915, Einstein presented his general theory of relativity, redefining gravity not as a force, but as the warping of spacetime itself. Imagine spacetime as a giant fabric. When a massive object like the sun sits on it, the fabric curves, and smaller objects like Earth roll along that curve. Planets orbit stars, not because they are pulled by an invisible string, but because they are following the natural paths carved into the geometry of space. This warping explains not only planetary motion, but the grand architecture of the cosmos. Galaxies, those vast islands of stars owe their very existence to gravity. Billions of years ago, tiny fluctuations in the early universe grew under gravity's pull, attracting more and more matter, until they became the galaxies we see today. Without gravity, there would be no galaxies, no stars, no planets, and no life. The cosmos would be a thin soup of particles drifting endlessly. But gravity pulled matter together, igniting stars, forging elements, and building the structures that make our universe rich and complex. Inside galaxies, gravity choreographs a cosmic dance. Stars orbit the galactic center, bound together by the combined pull of billions of suns. The Milky Way, our home galaxy, spins majestically because of gravity, with stars taking hundreds of millions of years to complete a single orbit. And yet, when astronomers measured these motions, they found something strange. Stars on the outskirts moved faster than Newtonian physics predicted. This led to one of the greatest mysteries in modern astrophysics: the presence of dark matter. Gravity revealed its hidden hand, showing us there's more to the universe than meets the eye. Gravity doesn't just hold things together, it bends reality itself. One of Einstein's boldest predictions was gravitational lensing. Massive objects like galaxies can bend light, acting like cosmic magnifying glasses. Today, telescopes capture stunning images of distant galaxies stretched and distorted by this effect. Direct evidence that gravity warps space. On an even grander scale, gravity governs black holes, the most extreme objects in the universe. When a massive star collapses under its own gravity, it creates a region so dense that not even light can escape. Here, gravity doesn't just curve space to emit, it tears it into a singularity, where our current laws of physics break down. For decades, Einstein's equations predicted that massive objects in motion should create ripples in spacetime. Gravitational waves, like waves spreading across a pond. These distortions travel through the universe at the speed of light. But they were so faint that Einstein himself doubted we would ever detect them. Then, in 2015, a century after his theory, scientists with the LIGO Observatory made history. They recorded the first gravitational waves, produced by two black holes colliding over 1 billion light-years away. For the first time, humanity didn't just see the universe, we could hear it through the music of space-time itself. But gravity is not alone. The universe is also expanding, driven by another mysterious ingredient: dark energy. For billions of years, gravity fought to pull galaxies together while expansion pushed them apart. At first, scientists assumed gravity would eventually slow the expansion. Yet observations revealed the opposite. The expansion is accelerating, overpowering gravity on the largest scales. This cosmic tug-of-war remains one of the greatest unsolved puzzles. It's easy to think of gravity as only a cosmic phenomenon, but it shapes our daily lives too. Without gravity, Earth would never have an atmosphere, oceans, or the conditions for life. Our tides rise and fall thanks to the moon's pull. GPS satellites must account for relativistic time shifts caused by Earth's gravity, or else our navigation systems would fail. Even our sense of time itself is warped by gravity. Clocks run slightly slower, closer to Earth and farther away, a small but measurable effect. Gravity is both intimate and infinite. It shapes our steps on the ground and the motion of galaxies across billions of light. It is the thread that ties the ordinary to the extraordinary, linking the fall of an apple to the birth of a star. Yet despite its familiarity, gravity hides secrets. We still don't know how to fully unite it with quantum mechanics, the theory governing the microscopic world. To reconcile these two, physicists search for a theory of quantum gravity, a framework that could explain everything from black holes to the Big Bang. As we gaze up at the night sky, we are not just looking at stars. We are witnessing the power of gravity shaping the universe itself. It binds galaxies, bends light, warps time, and carries the echoes of cosmic collisions. And though we have learned so much, gravity reminds us there's always more to discover, that the universe is both our home and our greatest mystery.
The universe hides more than we can see. Subscribe to Stellar Equation and keep exploring the unknown.